Okay, we're going to continue looking at finding the area of regular polygons, but I would suggest that this is actually more information than what you actually need. We should be able to find the area of a regular polygon with only one number. Okay, so I'm going to go to this slide. Your book gives you a formula. I'm not going to use it. If you want it, you can have it. It's right here. It's a half times your apothem times the perimeter. I like the idea of if we find the area of a triangle multiplied by the number of triangles, that will also get the area of a regular polygon. So we're going to stick with that method. We're going to look at this one. I give you a regular hexagon. So I'm going to really pull out that triangle inside, because if I can find the area of that triangle, I just need to take it times 6. So drawing out my triangle, best as possible, there it is. I know that I have a base in here of 3 meters. And I'm really looking for the height of this thing. I'm going to draw it in a different color. I'm looking for the height. If I can find the height, I know that I can find the area of that triangle. And one way that we can do this is by using trigonometry. But in order to do this, I'm going to need to use the right triangle. So in this case, I don't want all of 3 meters. I just want 1.5 meters. And I also want to find a central angle measure, which we did way back in example 1. I remember to find a central angle measure, we take 360 degrees divided by the number of triangles or number of sides, which in this case is 6 again. So 360 divided by 6 gets me 30. So all of this, is 60, getting ahead of myself. So all of this angle measuring here is 60 degrees. But when I draw in the apothem or the height, I'm really cutting that 60 in half, getting me an angle measure of 30 degrees. You can, in this case, use special triangles if you want. It doesn't always work. It only works if you have your special angle measures of 30, 60, or 45. So I would recommend just using trig to get you these values, because trigonometry will always work. So now I'm going to use my angle measure of 30, the opposite side of 1.5, and my height h, which I know is tangent of 30 being equal to 1.5 over h. We multiply both sides by h, so h tangent of 30 equals 1.5, and then we divide it over. H is going to equal 1.5 divided by tangent of 30, which will get us approximately 2.6. Which should now give us enough information to find the area of our triangle. So I'm going to scroll down, give myself a little bit more space. The area of my triangle, remember to find that, is 1/2 base times height. Our base of our entire triangle is 3, and I really would use 3 because then we won't have to multiply by near as many triangles. So times 3 times our height, which we just found was 2.6. And I'm also going to multiply by the number of triangles. This is one triangle right now, but I need to multiply by the total number of triangles, which, since it's a hexagon in here, we know that there are 6 triangles. So I'm also going to multiply this all by 6. And when I multiply all of that together, that's going to get me a value of approximately 23.4 meters squared, which does represent the area of my entire regular hexagon.